Hidden React architecture patterns that senior developers actually use. It's an article written by Michael Stefanow on the website javascript.plainenglish.io. React is one of my main tools, and I'm always open to upgrading my skills, learning new things, getting better at it. So I'm interested in these architectural patterns, if I can learn something from this. React architecture patterns have revolutionized how we build complex user interfaces. While most developers master basics, senior developers actually leverage advanced patterns to create truly exceptional applications. These sophisticated approaches help us create reusable, maintainable, and scalable components that stand the test of time. Design patterns in React are essentially well-established solutions to common development challenges. Furthermore, React design patterns help organize code in ways that promote readability and scalability, skills that separate junior from senior developers. Many businesses specifically rely on these React.js design patterns to develop high-performing applications that enhance user experience and drive growth. Through React component patterns, we can take our React skills to the next level and build better, more efficient applications. In this article, I will share the hidden architectural patterns that senior developers use daily but rarely discuss in basic tutorials. I always wondered why this is not more commonly taught for basic tutorials, because I think things like this should be in habit. And the best time to learn the habit is when we're beginners, when there is no bad habits. Another argument that can be made, I think, is that you should be learning basics first, like the syntaxes and things, but isn't this one of the basics? I don't know. Let me know what you guys think. Compound component architecture for shared state. Among senior React developers, the compound component pattern stands out as an elegant solution for managing shared state. Instead of relying on complex state management libraries, this pattern creates components that work together through a common parent component. The core idea is simple yet powerful. Multiple components share implicit state without proper drilling. Consider how HTML select and option naturally work together. Compound components in React achieve the same intuitive relationship. To implement this pattern, follow these steps. Number 1, create a parent component managing shared state and logic. Number 2, define child components with specific responsibilities. Number 3, establish communication between parent and children. Number 4, render children with proper integration. Two primary implementation approaches exist. Using react.children.map with clone element. So we have a function, we have constant with useState, and we return react.children.map props.children, and for each child we react clone element and child open the toggle. However, this limits nesting depth. For greater flexibility, use the context API. So toggle context create context. Context I've never really used before. Function toggle children. We have use state on and set on. And then we have the toggle context provider value on toggle set on, and its toggle just turns it on and off. This approach enables building more intuitive, maintainable React component patterns with cleaner APIs and better organized communication. Prop getters and collections for reusable interactions. Prop getters represent one of the most powerful React architectural patterns senior developers employ for creating truly reusable components. This pattern originated in the Downshift library and solves a critical problem in component design. When building flexible components, we often face a dilemma. How do we allow users to add their own event handlers without breaking the component's internal functionality? Prop getters elegantly address this challenge by providing functions that return prop objects with properly composed event handlers. The core of this pattern is a simple utility function. We have a constant, we have call all equals to function that calls another function that calls another function, which is a for each that calls within for each is another function. This function allows multiple handlers to be called for a single event. A typical implementation looks like this. So we have get toggler props equals to props. So props is the input to a function. Rather than exposing numerous individual props, we provide a concise set of prop getter functions with meaningful names that naturally connect to their corresponding JS elements. So we have const on and get toggle props. Use toggle Okay. This pattern offers notable advantages over direct prop passing. First, it handles accessibility attributes automatically. Second, it manages event composition transparently. Finally, it provides a cleaner API that prevents handler creep in complex components. Several production-grade libraries utilize this pattern, including Downshift, React Table, and Reach Tooltip. When implemented properly, prop getters create intuitive, customizable interfaces that maintain functionality while giving developers complete rendering background. Rendering control, Controlled versus uncontrolled components in pattern design. Understanding the distinction between controlled and uncontrolled components represents a fundamental architectural decision in React development. This pattern choice significantly impacts how your components handle and maintain state. In controlled components, React manages the component's state directly. The form input values derive from React state with updates occurring through event handlers that modify the state. This creates a single source of truth, making data flow predictable and consistent throughout your application. Whenever a user interacts with an input element, React intercepts the change, updates state, and re-renders with the new value. Conversely, uncontrolled components store their state internally within the DOM. These components rely on refs to access current values directly from the DOM. Typically, when needed, like during form submission, since React doesn't re-render with every keystroke, uncontrolled components sometimes offer better performance, particularly for large forms. Senior developers strategically choose between these patterns based on specific needs. Use controlled components when requiring validation, synchronizing values across components, or implementing complex form logic. Or opt for uncontrolled components when prioritizing simplicity, performance, or integrating with non-React code. Additionally, the state initializer pattern allows components to reset to their initial state without full remounting, providing flexibility while maintaining component identity. Conclusion. Throughout this article, we've explored powerful React architectural patterns that distinguish senior developers from the rest. These patterns certainly go beyond the basic React knowledge, offering sophisticated solutions to common development challenges. Compound component architecture stands out as an elegant approach for managing shared state without excessive prop drilling. This pattern creates an intuitive component relationship through context or clever cloning techniques, ultimately resulting in cleaner, more maintainable code. Additionally, prop getters provide remarkable flexibility for component interactions while preserving internal functionality. Their ability to compose event handlers and manage accessibility attributes makes them indispensable for creating truly reusable components. The strategic choice between controlled and uncontrolled components also demonstrates advanced architectural thinking. Senior developers choose one pattern over another based on specific project requirements rather than personal preference. After mastering these hidden patterns, you'll find yourself writing React code that's not just functional but also elegant, maintainable, and scalable. These approaches will undoubtedly elevate your development skills while solving complex UI challenges with surprising simplicity. React continues to evolve, though these architectural patterns remain relevant regardless of new features or API changes. They represent fundamental principles of component design rather than temporary solutions. We can apply these patterns immediately to improve existing code bases or incorporate them into new projects from the start. The result will be React applications that stand the test of time, components that remain understandable, extendable, and robust, even as applications grow in complexity. I have to say this article was a little bit above my level, but it's still cool to be exposed to something like this, these ideas, even if I don't get everything. Subconsciously, I'll probably digest this somehow. And I like this kind of things. I like discussing these kind of things, and I can't wait to get to that level to discuss this, have an opinion about it, and have an input. Thank you guys for watching. Let me know what you guys think of this. I'll see you in the next one.